Hello everybody and welcome back. We are looking at the top of page 10 and this is going to be a brief video that just sort of sums up the discussion that we had on the previous page into one definition. Okay, so let's suppose that we have a function s equals f of t and it represents the position of an object at time t. Same situation as what we looked at in the previous example. The average velocity of our function on the interval is given by, here's the notation that we introduced. AV stands for average velocity on the interval a to b, and it's just going to be the change in distance, how far we move, that's f of b minus f of a, over b minus a, okay, the change in time. Notice that that's exactly the same formula for average rate of change, just in this special context of position. Okay, and then one observation that we also talked about in the last example is that if you look at this average velocity over the interval from a to a plus h, and you let h approach 0, then what you approach is the instantaneous velocity. Okay, of the object right at t equals a. And notice there's a new piece of notation for that. So this IV that you see, that represents instantaneous velocity at t equals a. That's just our way of writing down instantaneous velocity. Okay, now a couple of notes on this. So let's talk about units first. That's important. So units of average and instantaneous velocity are units of s per units of t. What do we mean by that? Well, s and t are just our output and our input variables. Okay, so it's a way of emphasizing that we're calculating a rise over a run. Okay, so for example, if s is measured in meters and t is measured in seconds, then velocity is going to be measured in meters per second. Okay, and then the second comment here, AV of AB, we made that comment above, just reminding you that when you look at this formula, f of b minus f of a over b minus a, that's just an average rate of change. Okay, just we're measuring the average rate of change of position relative to time.